A knife gate valve body can be cast accurately and still fail the OEM's intent if the supplier is working from an unclear product definition. A flange face may fit nominally while bore alignment, sealing geometry, gate path features, or machined mounting points remain open to interpretation. Once tooling, casting, or machining begins, those omissions become expensive decisions rather than simple questions. Build-to-print work depends on a clear ownership boundary. The OEM controls the valve architecture, operating intent, performance requirements, and final assembly validation. The manufacturing partner produces the component from the approved drawing, model, sample, and specification package. That partner can identify manufacturability concerns, but it does not assume product design authority. The first requirement is a revision-managed drawing that establishes the manufacturing baseline. It should identify the material grade, dimensional datums, functional interfaces, machining zones, surface expectations, tolerances, and acceptance requirements. Critical characteristics need to be visibly marked, especially flange faces, bolt patterns, bores, gate paths, sealing locations, and mounting features. The package should also distinguish functional dimensions from informational dimensions, so inspection effort follows the features that affect fit, assembly, sealing, and verification. Samples require the same discipline. A physical part can reveal geometry, surface condition, and assembly context, but it may be worn, modified, or missing internal requirements. Before production begins, the OEM should define whether the drawing, model, sample, or an approved deviation takes precedence if conflict appears. Without that hierarchy, a supplier may reproduce an obsolete feature while believing it has met the order. Material requirements should be equally specific. A broad material family is not enough. The RFQ needs the required grade, applicable heat treatment, corrosion or surface requirements, and the evidence needed to confirm compliance. Any substitution procedure must be customer approved. Material and traceability expectations connect the finished component to the melt or lot evidence required by the purchase order. Inspection requirements belong in the quotation package, not after the supplier has planned production. Chemical analysis, hardness, tensile properties, dimensional reports, non-destructive testing, pressure testing, and requested inspection documentation can affect routing, test planning, cost, and lead time. The buyer should define which tests apply, their required extent, acceptance criteria, and reporting expectations. A disciplined review process protects both schedule and technical intent. Early DFM feedback can identify thin sections that are difficult to fill, unstable core features, inadequate machining stock, shrinkage-prone geometry, inaccessible datums, fixture constraints, tool clearance concerns, or tolerances that cannot be verified repeatably. These observations are valuable because they expose manufacturing risk before material is committed. But DFM is a manufacturability review, not an informal redesign process. A proposed adjustment must be documented, separated from a simple clarification, and approved in writing before it becomes the production baseline. A revised drawing note, approved deviation, or signed clarification record can establish that control. Verbal direction may resolve a question quickly, but it should not direct tooling, casting, or machining without a controlled record. For approval gates, provide a practical release structure. First, align the drawing, model, sample where needed, and purchase order revision. Next, document DFM observations and identify whether each item is a clarification or a proposed change. Then obtain written customer approval for any change that affects a controlled requirement. Finally, approve first article and inspection evidence before recurring production begins. First article review should compare the component with controlled requirements, not with memory of prior discussions. Dimensional reports should follow the drawing logic, linking critical faces, bores, bolt locations, mounting features, and sealing-related geometry to the approved datum system. Material records, applicable NDT reports, and pressure test records should identify the method, scope, criteria, and result required for acceptance. Traceability completes the release file. The material certificate, heat or lot identity where applicable, machining route, inspection records, and package marking should lead back to the customer-controlled part number and revision. When that chain is complete, The OEM can compare suppliers on visible manufacturing scope and evidence, rather than on unit price alone.